Okay, welcome. In this video, we're going to start this new subject called Rationalize the Denominator. That's what we are going to do in the next classes. So, what does it mean to rationalize the denominator? Well, rationalizing the denominator is when you move a root, like a square root or a cube root, from the bottom of a fraction to the top. So for example, if you have 1 over the square root of 2, after you rationalize the denominator, you get the square root of 2 over 2. That is the same fraction, right? So we're going to learn how to go from the fraction to the left to the fraction to the right. Right? As you can see, we got rid of the square root from the denominator. And if we end up with a square root in the numerator, that's fine. Or if we get rid of all the square roots, that is fine. So let's see some examples to learn how to rationalize the denominator. Okay, we have this example. It says rationalize the denominator of this fraction, this expression, 1 over the square root of 2. So what do? Well, we have to take our expression and multiply it by what? I'm going to use a different color just to show you. We're going to multiply by the very same square root that we have in the denominator. We have to multiply the numerator and the denominator. Okay, I have a square root of 2, so I multiply by the square root of 2 over the square root of 2. If I had the square root of 3, then I have to multiply by the square root of 3, both the numerator and the denominator. If I have the square root of 5, the square root of 7, I have to multiply by that very same square root, the numerator and the denominator. Okay, so why square root of 2 over square root of 2? Because square root of 2 divided by the same thing is 1, right? So I am multiplying by 1. This is like multiplying by 1. So I'm not changing my problem. That's why I have to have the same things in the numerator and the denominator. Okay, so let's continue. Now, what do we get if we multiply those two expressions? Well, remember that in product of fractions, we have to multiply both numerators and both denominators, right? Please do not cross multiply. What is the product of 1 times the square root of 2? Well, the square root of 2. Now, what is the square root of 2 times the square root of 2? Well, that is the square root of 2 by 2 inside the square root, right? Just like we learned in the last partial. And of course we can take out, well, I'm just going to copy the numerator. We can take out those two 2's, just 1, 2, and inside we have 1. Okay, exactly what we learned in class. So what do we get? The square root of 2 times, what is 2 times the square root of 1? Well, remember that the square root of 1 is 1. I'm going to write it. And the answer will be the square root of 2 over 2, right? The example, the result that I just showed you in the last slide. Okay, so that's it. We just got rid of the square roots in the denominator. Okay, let's see another example with. So we have to rationalize the denominator. Let's see. Sorry about that, some technical problems. Okay, now let's continue with another example. We have 3 over the square root of 6, right? And we have to rationalize the denominator. Okay, so when you have square roots, you always have to multiply by that very same root, the numerator and the denominator. Remember, again, it is in the numerator and the denominator, so it's like multiplying by 1, right? This is like multiplying by 1. and I'm not changing my problem. So what do we get? 3 times the square root of 6, the square root of 6 times the square root of 6. What do we get? 3 times the square root of 6 is what? 3 times the square root of 6. Please do not multiply 3 and 6, because 6 is inside the square root, 3 is outside, right? 6 is inside, 3 is outside, we cannot multiply them. And we have the square root of 6 times the square root of 6. You can write the square root of 6 by 6, 6 times 6, but I can write it like this too, right? The square root of 6 times the square root of 6 is the square root of 6 squared. Okay, it's the same thing. Now we have the numerator. I cannot do anything to that. I cannot simplify anything. But what is the square of the square root of 6? Well, it's just 6, right? Because you are going to simplify this square with this root, right? They are operations that cancel each other. Let's say that cancel. They simplify each other. So what can we do? We can simplify the fraction. 3 divided by 3 is 1, and 6 divided by 3 is 2. So we get the square root of 6 times 1 is just the square root of 6, and 2 in the denominator. And that's the answer. We cannot simplify anything else. We cannot simplify 6 and 2, right? Because again, 6 is inside the square root and 2 isn't. So we cannot divide them. So that's the answer. Okay, let's solve one more example, more interesting example. Okay, we have these examples. Rationalize the denominator of, we have 2 plus the square root of 3 divided by 8 minus the square root of 3. So in this case, we have a binomial in the denominator, right? So we cannot just multiply by the square root of 3. We cannot do this like we did before. Okay, this is wrong. We have to do something else. Let's remember algebra, and let's remember what you know as difference of squares. Remember difference of squares? If you had a plus b multiplied by a minus b, you got a squared minus b squared. This is the difference of squares. So we have to remember that we have the product of conjugate binomials, remember? And the product of conjugate binomials is the difference of squares. So let's use that to get rid of the square root here. How do we use difference of squares? Okay, I'm just going to look at my denominator. I'm going to forget, for now of course, the numerator, and I'm going to find the conjugate binomial of my denominator. What is the conjugate binomial of 8 minus the square root of 3? Where, according to this, it's the very same terms, but we just have to change the sign of one term. So let's say I'm changing the sign of the square root of 3. And remember that I have to have the same in the numerator. Again, it is like multiplying by 1, so I'm not changing my problem. So let's multiply. Let's see. I have 2 plus the square root of 3 times 8 plus the square root of 3. And down there, I have the product of two conjugate binomials. They are two conjugate binomials. So I'm going to follow the rule of difference of squares. So what do we get? The square of the first term minus the square of the second term. Okay, I'm just using the rule of difference of squares. Let me just get rid of these lines so you don't get confused. So what do we get? I have this thing here. We are going to multiply just like we learned in the last partial, and I have to find the square of 8. Well, that's easy. It's 64 minus what is the square of the square root of 3? Remember, like the previous example, we can simplify the square root and the square. Okay? If I square a square root is like not doing anything to the number, so I have 3. Okay? Because the square root is going to go with the square. So what do we get? I have to multiply the numerator. 64 minus 3 is 61, that's easy. But what do we get when we multiply those binomials? Well, 2 times 8 is 16. Okay, we studied that. 2 times the square root of 3 is positive times a positive is a positive. 2 times the square root of 3, the square root of 3 times 8 is, they are positive, right? Positive times a positive. And the square root of 3 times the square root of 3, positive, the square root of 3 times the square root of 3. So you should already know that we are going to have 6 plus 2 the square root of 3 plus 8 the square root of 3 plus, and what is the square root of 3 times 3? Yes, it's 3, right? We learned that in the last partial. So let's just simplify the numerator. We can add 16 and 3, 19 plus, and we can add 2 plus 8, it's 10, and we just copy the square root, and that's the answer. Okay, so we will continue tomorrow. We're going to solve some more examples and questions, and well, we're going to solve a lot of exercises because that's how we learn math. Okay, thanks for watching.